Now let's see an example on deleting a node from this B plus tree. So whenever we talk about deletion from B tree or B plus tree, you should always consider the case of underflow. So what is underflow is, if you are going to delete an entry, then the minimum number of entries required in a node might fall below the required number. So what is the minimum number of entries that are required in a node in case of B plus tree is, if we consider that order is 5, let's say P, that is P, then the minimum number of keys or the minimum number of entries required in any node is, except the root node is, P by 2 minus 1. Right? So this is the condition you should always be careful about. Now if I substitute in place of P5, this number is going to be 2. So what does it mean? Every node except the root node is at least supposed to have 2 keys, right? Now check this. All the nodes are actually containing at least 2 except the root. So root is an exception. In the root you can even have 1 key, right? Okay, now let's try to delete one entry, and let's say I want to delete key 19, right? Now if I delete key 19, what happens is, first I have to find out the leaf in which key 19 is present, right? Now check this, 17, so 19 will be greater than 17, therefore come to the right, and now here 19 will be less than 24, so come to the left. So this is the leaf which is supposed to contain 19 if at all it is present, and yes, it is present, right? Okay, now you can delete the entry containing 19. See, even though I am just showing you the key that is going to be deleted, in actual it is also going to contain a pointer along with that, right? It is going to contain the key 19, along with 19 there will also be a pointer, but we are not showing it here, right? Keep that in mind. Okay, now I am going to delete 19. Now according to the algorithm that I have shown you in the previous video, now whenever you delete any key, you just check whether that key is present in the non-leaf, right? So which means, is it present here? Not present. Is it present here? Not present. Therefore you need not do anything, and also check for the underflow condition. So what is underflow condition mean? You should at least have 2 keys. Yes, this is at least having 2 keys, isn't it? At least having 2 keys. Therefore there is no underflow and no rearrangement is required. In case if there is underflow, you might have to do some rearrangements, right? So as of now there is no problem with that, leave it. Okay, and now next one is delete 20. Again we follow the same procedure. Search for the leaf which is supposed to contain 20, right? And from there you are going to, now since 20 is not present there, let's say instead of 20 I want to delete 22. Okay, since 20 is not present here, let me go with 22, right? So what happens if you try to delete 20? Since it is not present here, it will just show that it is not present. Okay, now 22 is greater than 17, so go to the right subtree, and 22 is less than 24, therefore go to the left subtree. Yes, now you are here. Now you are going to delete 22. Okay, let me delete 22. Now if you delete 22, you can clearly see that there is an underflow here. So what is underflow? We are having less than 2 keys there. Now what should we do in that case? I told you, we can handle it in 2 ways. One of the ways is check with the siblings, and if any of the siblings is having more than the required number of nodes, then we can do some rearrangements. Now if you see this, the sibling is having 3 nodes, but the minimum number of nodes required or minimum number of keys is required is 2. Therefore you can take one of the key here and you can move it over here, right? So you can move 24 over here, but only thing is, if I am going to write 24 here, according to the definition of the B tree or B plus tree, according to the definition of B plus tree, we have seen that if 24 is present here, then its right subtree is going to contain 24, isn't it? Therefore if I write 24 here and if I delete it here, then I cannot have 24 here, right? So you can replace it with smallest one in the right subtree. So what is the smallest one in the right subtree? 27. So just replace it with 27 and we are done with that, right? And also check that whatever node you have, whatever key you have deleted is not present in any of the non-leaves. So which means 22 is not present here and 22 is not present here. So this is how we are using rearrangements in order to balance the underflow. Got it? So let's see other cases with other deletions. Okay.